Okay, so in today's class, I trying to explain the transform of function. So to understand this kind of concept, you need to figure out the relation between graph and steps. It means that if you have graph, like here's f of x, and it by like scaling or like shifting to the edge of x, and can you write down a step about this transform, or like give you a steps? Can you write down the graph that obtained from f? And also, you still need to figure out what is the relation between step and the formula. So the formula you can write down as this like this. So it in today's class, I trying to like show you what is the relation between um, we say between the formula and the graph, and it can be understand by the compose of function, but it turns out that everyone was really confused, and when I think about it, I think it's not really straightforward like way to understand the whole concept. So in this video, I will tell you what is the step relation with formula and the step relation with its graph. And then if kind of question asked like you see the transformation on the graph, then what is the formula you can obtain? So you all you need to do is that you write down, you see the graph and you write down the steps, and you you obtain the formula. Okay, so for like simply express in this video, I will write down step like this. So H stands for horizontal, or V, and the V stands for vertical. And this arrow here means shift, and should like shift to left, shift to upward, shift rightward, shift downward. Okay, and across here, I means times. It means scaling. Okay, so it's horizontally shift to left by using 1, and it's horizontally scaling by 2. Okay, everyone can read this. Okay, now so first we want to explain what is step relation between the relation between step and formula. Okay, so if you have your original equation like this, and then the question asks you what is the transform after first, like horizontally shift by f by 1 and blah blah blah. Okay, so when you see like this kind of like steps, always need to be remembered there is big difference between the horizontal steps and the vertical steps. Okay, so for every horizontal steps, shift to the right by n unit, you replace x by x minus n. And scaling by n units, you replace x by 1 over n, right? And reflect across y-axis, there's a confused, but you might see that a reflection be, like across y unit is actually work on its x coordinate, right? Okay, remember, so reflect across y-axis is actually a horizontal step, and what it actually do is replace x by minus x. Okay, so there's also some vertical step, but it's quite straightforward, like shifting up by n unit, you just plus n, and scaling, you just times n, and reflect is times negative. Okay, so back to this example, how can we obtain the final formula? First, like horizontal shift to the left by unit 1, right? So you're doing what? You replace x by x plus 1. What does it mean? Like you see there's x here, right? And then you replace x by a bracket, and you fill in the bracket by x plus 1. Okay, let's what x replace x by x plus 1 mean. Okay, so the second step, the vertical scaling by 2. what should you do? Like you you take the bracket of whole equation and your right hand side, and you you scaling by 2. Okay, so now you have this. Then the third step asks you to horizontal scaling by 1 over 2. But scaling by 1 over 2 means that you have to replace x by 2x, right? It's reciprocal. So what you do is that you replace every x here via bracket, and then you plug in bracket by 2x. Okay, so now we go into this step. I just take the bracket out here, and then you reflex across x-axis, which means that you put a negative sign at the whole bracket of right hand side. So your final answer should be look like this. Okay, so we do a first, like example 2 is a quite complex, like we do horizontal shifting to the right by unit 2. So in this step, right, you do the same thing, right? It's replaced, right? Replaced by, so you replace x by a bracket, and you plug in x minus 2. X minus 2. Okay, then for scaling by 3, you take a whole bracket of all the stuff in the right hand side and you times by 3. Okay, so that will be your final answer. You might notice that I factor out all the stuff inside the square root. Okay, that's how you get from steps to the formula. Okay, now if we have set a formula, how can we obtain steps? Okay, so if you write down steps, always remember that you can write down like several of horizontal steps and like several of vertical steps, but it doesn't matter like you do a horizontal step first or vertical step first. Like you can do this first, second, third, and you do the vertical, 4, 5, 6. It's okay, or you can do like you can do the vertical first, like 1, 2, 3, and 4, 5, 6. And if you are a rocker or you don't really do some cool stuff, you can do like 1, 2, 3, 4, 5, 6. So the main point is that you can like change the order in horizontal step, but you can like kind of shuffle the horizontal step and the vertical step. It doesn't really matter. Okay, so read the H steps, far to close and reversely, and read the vertical step close to far and not reversely. Like what can you see? Like what does the far to close mean? Like in here you have horizontal step, right? So far is that you read this first, and reversely means that it plus 1, so it's actually shift to the left by 1. Okay, and then close to x there is a scaling, so now you do a horizontal scaling by 1 over 3. Okay, so the vertical step should be some step outside this f of x. Okay, so it's read from close to far. So close means you read the negative 2 first, right? So it's vertical scaling by negative 2. Or you can separate these the two step as the vertical scaling by 2, and then you reflect across x. Okay, so but it doesn't matter, like scaling you times 2 and it's equals to times 2 and then you times minus 1, right? Okay, it doesn't matter, so you can write down this is a step in the text 1, and then you do what you read from close to the far, right? So the next step should be vertical shifting to what? Upward by unit 2, right? So then you can like you can choose like, so for simply you might always write down the horizontal step first and vertical step first, or if you want you can write a vertical step first and then horizontal step. It doesn't really matter. So I can explain this kind of like, if you have this kind of like smiling face and then you shift horizontally, or you shrink horizontally, or you reflect like, or reflect horizontally, it never affect any like, you do a lot of like stuff on your x coordinate, but it's really nothing to do with your y coordinate, right? Your eyes always on this same level, it never changes, right? So that's why your horizontal step never affect your vertical step. They doesn't like have things to do with each other. Okay, so a third example should be this. So the horizontal step should be read in the bracket of f of x, right? And you read from far to close. But in this case, the far case will be 2, right? So actually consists with not matter. So you do horizontal scaling by 1 over 2 first. Why? Because 2 is far. You do, if you have a bracket here, you do the plus and then you do scaling, right? But to write down step, you always read from far to close. Now you need to read the close. The close is what? Plus 1, which is shift to the left by unit 1. Okay? So what is your y? But the y should be read from close to far. So now your whole f is here, right? What is close 1? It's plus 3, right? So you do the vertical shifting upward by unit 3, right? And then you do the vertical scaling by -2. Okay? Okay, so now we already know what is from steps to formula, right? And if I give you a formula, how can you write down the step? So we already figured out this. Now we're trying to explain what is relation between graph and steps. Okay, so now we have this kind of set of graph. So if you find this graph, 2 steps, always follow these three steps. One is choose good points. You might doesn't know what is good point means, so basically choose 2 point is enough. But these 2 point can be horizontal one. Like in this case, you can, if you choose this and this, it's not good enough. Why? Because this 2 point was located in the same horizontal line, so this is not enough. So in this case, you might add some points at here. So, but in this kind of thing, like this 2 point is enough because they are not located in the same horizontal line and not in the same vertical line. Okay, so why we should choose like this kind of good point? Because we want to see like how is the graph scaling. Okay, like from this graph to this graph, it's like it's 1 unit and it's 2 units. So we should know that the horizontal scaling is by 2, right? And the vertical scaling is by 3, right? And in this content, you should always notice about there is kind of reflection happens here. Okay, what does it mean? Like if you see this kind of graph in translate, oh, it's not really clear, but the graph should like look like this. Okay, so is the scaling is 3 here, but you kind of seems like they reflect across y-axis in this setting, right? So reflect during Y is the horizontal. So it actually scaling by what? By -3. So it's really important. So if you do have like reflection, you should put a negative between your scaling. So you read is 3 times bigger than this, but you actually need a -3. Then for vertically, there is like is 1 unit and is 2 units. So it's actually tied just, but it doesn't have reflection to like across to X, right? So it's just 2. Okay. So for further example, like list to list, here is is 1 unit. Here is 2 unit. It's not really true, but it's my setting. So it's 1 unit, and it does have a reflection, right? So the horizontal scaling should be -2. And then the the height of these two graphs is the same, but it actually reflects to Y, so it's -1. Okay, so you choose your good point and you read the scaling of between two graphs, and then you do the shift. So to clarify these steps, I give you an example. Like you have this kind of graph, it's f of x, and this one we say is y is h of x. So we want to start from f of x, and we try to obtain h of x. So what do you do? Like you choose good point, right? What is the good point here? I choose this and this. And these two is enough, right? Because they are not in the same horizontal line, not in the same vertical line, right? So actually, you should check that this point would goes to here, right? And this point should goes to here. Okay. So what is the horizontal? So you can see horizontal here. The unit is what? Is -3 minus -1, which is 2, right? And here, the horizontal from this point to point is 4, right? And does it reflect over Y? No, right? So it's nothing but just horizontal scaling by 2, right? Because it's a 2, it's times 2, right? So if you by doing these steps, you might figure out that if you do a horizontally scaling by 2, you actually send -3, 4 to -6, right? Because you do the scaling, right? So you send the -3 to negative it's times 2, right? Can you should wait, why can't, right? This to list is times 2. Okay, and horizontally, so it's only affect on the x coordinate. And now you do the scaling, right? So remember, like you want the -3, 4 is this point. You want to send this point to here, right? So you want to send -6 to 3, right? So what you actually do, like you should shift to the right by unit 9, right? So that then your -6, 4 can be shifted to this one. Okay, so this one to this one. So you might wondering like, is blue one or like shift to the blue one already? You can check by that. You already shift in this kind of horizontal steps. You already shift this point here to here, and send blue point here to here. So now you do the vertical shift. So what is the vertical? So you should now we check the vertical shift. So here the height here is 3, right? 4 minus 1, and the height here is what? Is also 3, right? But does it reflect across f of x? Yes, right? Because you see this little tail here is the upside word, right? So it's vertical scaling by 1, but you need to plug in -1 because it does I shouldn't, because it does like reflect across the x, right? Okay, so now you shift 3 4 to, by doing this horizontal by doing this vertical scaling, you send 3 4 to what? You don't affect the x coordinate, but you shift 4 to -4, right? So this point shift here, and the next step you shift to -4, and then the -4 is exactly what you want here, right? So it doesn't shift anymore. Okay, then you shift 3.4 to, so that's how you obtain. So what you can see in this picture, you can write down the step, which is you horizontally scaling by 2, and then you horizontal shift to the right by 9, and you do the vertical scaling by -1, and then you don't do further like vertical shift. Okay, so one thing I should remind you is that you never do the scaling after the shift. Why? So we always check the scaling first, and then we do the shift. If you do the shift first, then scaling, then what will happen? Like in this example, we want to shift this small guy like to the 2 times big 1. Okay, so if we do shift and shift then into the same horizontal line, and then we scaling. But when you scaling, you actually send this point to the two, like two times away from your x-axis, right? So if you do the shift then you do scaling, you cannot get the right y coordinate. That's why you should always think about like you should do the scaling and then you do a shift. Okay. Okay, so now is the furthest, like, so now we know how, when you get a graph, how you obtain the steps. So the final is the most simple one I put in the end. So it's like if you get a step, how you get a graph. It should be like most straightforward. You just follow the step, like see what you get. Like, but the most important things here is like make sure that you do consider all the important points. Like in your quiz too, a lot of people just like neglect this point, and it should be like transport to on your graph too. Okay. So for this one, you know that there is horizontals. Like in this case, we know like horizontal shift to the left right by unit 1, and then you do horizontal scaling by 2, and the vertical step should be shift downward by unit 1. Okay, so if this is your original graph, then what is your new? So you want to know, like for this point, you want to know the new coordinate of this point, right? So if you have this point, you have your x coordinate and your y coordinate. So you get the x coordinate of your new graph by doing what? By doing this step, right? So you shift to left is +1, right? And you scaling by 2 is times 2. So you get this kind of equation, like you scaling, you plus 1 and you times 2, you get 4. And for your y coordinate, you read your vertical step, right? So 4 here, you shifting downward by 1, so you get 3. So the corresponding point here, you get your new coordinate here. So 1.4 to the 4.3. Wait, right? So 4 is here, 3 is here, right? And then for 3, 4, 3, and then 3 by this equation you get 8, right? You plus 1 and you scaling 2, you get 8, right? And then y coordinate here, you minus 1, so you obtain 3. So 3, 4 here, you move to the point. The coordinate here should be like 8, 3, which is this point. Oh, why is so stupid? So this point goes to this point. Okay. So you shouldn't be confused here that the step here you should not be reversed. Like we shift to the right by unit 1, we directly adding 1 because we are now drawing on the coordinate plane. We are drawing, right? So you can directly like do the steps in the content. Do not confuse by the formula here. So step and the formula, you need to read the horizontal step like inverse. But here, if you directly do the steps and graph, you don't need to do reverse, right? So that's why the relation between graph and step is more straightforward. You don't need to really confuse, but you do really need to care about the relation between the steps and the formula. Okay, so if you have further question, you can email me or ask me for an additional office hour after this course. Okay, so then bye.